All right, welcome back to Year 12 Methods. So I'm just going to talk through the last chapter, 8F. Some of you have already moved on to this chapter, or at least the first half of it. So if you've already started 8F.1, then you can just skip this part of the video and jump up to the point where I'll start talking about all calculator potential questions. So this first component of the chapter is just using the calculator to do the inverse of what we were doing before. So before in the last chapter, what we were doing was given a probability of a certain random variable being above or below or between a actual number, like you are given the actual number, find me the probability. So that was the previous chapter 8E. This chapter is doing the opposite. So this chapter is, instead of giving you an x value to be above or below, this time they're giving you the probability. So they're giving you the part of the distribution. So it's above x. So it'll be over here somewhere. So they're giving you the area under the curve, or the probability, but you don't know the actual value. So we deal with this again on the calculator. So I'm just going to show you where to find this function on the calculator. So everything is in the same spot. So if I quickly get up now. So we want statistics mode, and anything to do with calculating or working with probabilities on the calculator, you want to go to distribution. Then you want to go normal. So binomial is when we had a discrete model or a discrete probability situation, where it was like a loss or a fail situation. This situation is a normal distribution, so we want the normal distribution. The NCD was the calculator function you were using in the previous chapter, and we want to do the inverse normal this time. So NCD was given a value, find me a probability. Inverse normal is the opposite. So give me a probability, find the value. So if we go back, so that's how you will get up the menu, and then you will just follow the steps for this example. So just explaining the result of this example. And there's also an TI equivalent how to get to that probability calculation. So I'll put a link for a video just here after the video. So once you're in that mode, all you have to do is click what area of the distribution you're working with. So left being like the left-hand side of the distribution, right being the right-hand side. Central is for when you have a even split of probability over the middle, and it has to be exactly over the middle, so exactly over the 50% middle line. So that'll be like 45 up to 55% of that chunk. So basically from, if that's the middle here, you would have to be evenly split over that. That's the only time you would use central. Then you would just type in the probability. The probability is just the area. So here it's saying find the probability. Find the value k for which the probability is 0.95 given a mean and a standard deviation. So you would fill in the standard deviation, the mean. The area is the probability, and it will just spit out the answer for you. So the answer is, again, the value on the bell curve x-axis. So the y-axis being how likely, and the x-axis being what is the value. So that is this 8F.1. We can do the same thing with this Z-score type system. It's just the Z-score is telling you how far in terms of a standard deviation away from the mean you are. So for example, I just picked out this random one here. So suppose Z has a standard normal distribution. So that means that we have, normal distribution, the mean is 0 and the standard deviation is 1. That's what that means. So every time you are talking about a Z-score, they will convert that X into a Z, and you know you are dealing with the mean being 0 value and the standard deviation is 1. And the answer to this in terms of that K is how many standard deviations. So that's really what that is equal to. And again, that is also equal to the formula that. So depending on the situation, you might want to use the formula. In other ways, you just want the K value. So in this case, if we use the calculator for this one, so again, we are working with a probability. trying to find a value. So again, that is using the inverse normal. So this one we'll actually do together. So we want to just double check that we are distribution, normal, inverse normal. Let me just double check. We are trying to find a value below this value. So we are on the left of the curve. The area was, I'm just going to have to double check everything, 0.17. The standard normal always has standard deviation of 1, mean of 0. And that comes out as a negative 0.95. Oh, hello. So that means the K value comes out to 0.95, and I think it was a 1, but let me just 4. So K is equal to that. You could get asked in the next chapter to do a bit of work with this formula, and that's what we're going to head on to next. Actually, before we move on to the next chapter, I'm just going to talk about a situation if you have a probability question where you have an interval to work between. So there's question 5. What you have to do is get some, basically you need a calculator to tell you this component of the question, and then a calculator to tell you this component of the question. So just quickly on question 5 here, find this. So this is just a normal question, nothing really fancy about it. So find the probability. So that will be an NCD question. Max of 72. So that would be negative 1 times 10 to the 99. 72. That was 10 and 80 from memory. All right, that's good to go. Draw me. Okay. So that area there is 0.212. Oh my God, I keep doing that. All right, then part B, find the probability of 72 x k 0.1. All right, so then you just have to use your knowledge of where you are on the curve to put this together. So for this one, we've got 72. So x less than 72. So we saw that, let's say if that's 72 here, we saw that that was 0.212. So I just recommend doing this with a diagram. It's not too hard if you use a diagram. If you try and just think about it and do it without a diagram, it can be a bit difficult. So then we want the area to be 0.1 up until a K value, whatever that K value is. So if you think about it, we are really asking the question of x less than or equal to K such that the probability is 312. So that area plus that area, well, if this one's 0.1, that one's 0.212, add them together. And we want to find the value K such that we are finding the probability of 0.312. That's how we approach those ones. And if I just give myself a bit more space. And then if we use inverse normal for this one, because we have a value and we want to find it using a probability, 0.312. 0.312. So all that's the same. 75.1. Okay, so that would be the the K value to answer that question there. All right. Okay, so this next chapter we're going to be doing something a little bit creative with the calculator. So we are going to be using the Z-score formula with the calculator. So we could use the calculator to find the value of this position here with the Z-score. So that K would be here. But you could also imagine, since that K is also equal to this formula here, which basically says how far is a x value away from the mean divided by the standard deviation. It's how many standard deviations is the x value away from the mean. Sometimes if we just want the k value in this position like this with the z, you just want how many standard deviations away are you. But you can also use this, if you put this 0.954 on the left-hand side of this equal sign, you can imagine that if we have the x value and maybe the standard deviation, you can actually solve for the mean. So let me show you what that looks like in a second. But what I've got here is a bit of a list of all the potential calculator style questions you could get, all in one little summary. So the first one was from the previous chapter 8e. So that was given a value, find the probability, type into the NCD mode. The second one was just then inverse normal, finding a value given a probability, chuck that in the inverse normal, find the value. The third one is something that was new in 8e, but also here today as well, which is using a z-score, which normalizes the mean to 0, standard deviation to 1. And that basically counts how far away from the mean are you in terms of standard deviations. You can put that in NCD if you have the value but don't know the probability. So same thing as before. If you don't know the probability, that's NCD. That will spit out the probability of that. So what's the probability of being 2.1 or more away from the mean of 0, or from the mean? And you could also do this technically with the inverse normal one, but you just get the idea. You can use the z-score along with these first two. And the last one is if you do not know the mean or the standard deviation, then you can actually replace the formula for the z-score in that k or the x value position. And what that will allow you to do is then use the calculator. So for this question here, if I was told the probability, I was told the x value, and to find the mean, but just keep in mind you can also find the standard deviation for this. Given one but not the other, you would use the formula. So you chuck the formula in that position. So replace that 20 with this. And the x would just be replaced with z because now we're talking about a z-score. You are given a probability. You would chuck all of that in the calculator. So this inequality would suggest that the z-score is above, i.e. the tail needs to be to the right. The probability is the area under the curve. We are using a z-score, so the standard deviation is 1, mean is 0, and that gives you a output. So that gives you this 1.036. Technically, that is how many standard deviations above the mean you are, above because it's positive, and that decimal is equal to this. You can then put that into that equation here, and then rearrange and solve. So you do that times 2, so that'd be 2.072, and you would rearrange, so that would become 20, take that. So that becomes 17.93. So that's how you find the mean or the standard deviation from the calculator using the probability, x values, and stuff like that. All right, so let me go to a bit more of a complicated question. And we'll do this one together first. All right, find the mean and standard deviation of a normally distributed variable. Okay, so you see this one, we've gotten a bunch of information, but we haven't gotten the mean or the standard deviation in the original case, the x variable. So that should be a red flag that we need to use, the z-score, in order to find these. Now, when you have two things you don't know, that probably means you need simultaneous equations. That's what that probably suggests. Two unknowns, I need two pieces of data or two formulas. So what data can we use here? So I am given a probability and an x value, so that's cool. But I need to use a z-score in order to relate this to the mean and the standard deviation. So if we replace the z-score and we use the z-score formula, then we obtain these two statements. So the x value is just that position there, subtract away the mean, divided by the standard deviation. Is that equal to the probability? All right. And if we do that, Then we can use the calculator. So it doesn't actually matter which mode. Actually, no, it does. We are given a probability and we want to find a value. So that is a inverse normal situation. So if we do that, so the tail is below, so that'll be left. This tail will be, the Z value is above this, so the tail needs to be the right. Area, 0.1, area, 0.15. Now this is a standard normal, or a Z-score, so the standard deviation has to be 1. The mean has to be 0, and this is just for the calculation. That's not the true values that we're trying to find. This is just the bastardized version using the Z-score. And this will tell us so this first one is left, 0.1. So that tells us the Z-score is equal to negative 1.28 equals 20. And the next one on the right, 0.15. That comes out to 1.036. All right, now we have two equations which we can get ready for simultaneous equations. Now, you should never do simultaneous equations algebraically if you can avoid it. So how do you know if you can avoid it? If you can write it out into a statement that looks like this, where x and y are your two unknowns, then you know you can put that in the calculator. So let's try to do that. So if we times by the standard deviation, times by the standard deviation, and then we can rearrange to have the mean out the front, and put the mean out the front. All right, this is what you can do now. I'll show you actually on the calculator. So you can go menu, equation mode. If you're doing this on TI, equation mode solver is also there as well. If you don't know how to use it, then go to YouTube. They will, if you type it in, you'll find it. Simultaneous equation mode, two unknowns. We had one mean, and then we had subtract 1.28. Equal to 20. We had a mean of 1.036. That was equal to 29. Bam, let's solve this bad boy. Okay, we have a mean of 24.97. Standard deviation of 3.886. So they will round up to 30.0 and 3.8990. So sim equation, G solve, graphics calculator solve, mean is 25.0, standard deviation was 3.90. Actually, I think it's 89 actually, if I rounded that properly. All right, and that's how you would solve that situation. So if you have multiple unknowns, red flag, you need to use simultaneous equations and try your best to rearrange it until it looks like this, and then you can put it straight in the calculator. All right, that should get you through most of it. Good luck.